It's also possible to analyze arguments using truth tables. We've seen how you can analyze arguments using Venn diagrams. Let's see how you can analyze arguments using truth tables. Take the statement, if you work hard, you will pass. That statement could be written, if you work hard, you pass. Then Joe works hard. So we could write that, if you're Joe, then you work hard. Therefore Joe will pass. Well, therefore if you're Joe, you pass. Now the logical representation of the entire argument is, if this is true and this is true, then this must be true. To write that out, we write, if this is true and this is true, then it follows that this is true. Okay, remember, the argument says if both premises are true, then your conclusion is true. So it says if the premises are both true, if both premises, then conclusion. We can set up a Venn diagram for this situation. We have the conditions J, W, and P, which can be true or false. So we would set our truth table up in the beginning. In the usual manner. And here we have it. Now, let's evaluate some of these premises. First of all, if W, then P. Then we'll evaluate if J, then W. Then we can evaluate the whole first part of this big conditional. If W, then P, and if J, then W. And finally, we can evaluate the whole argument. If W, then P, and if J, then W, then if J, then P. Now hopefully that's legible to you. It's a little hard to write these truth tables so that they come out real legible on an MPEG file. And it's a little hard to show them all, and it's a little hard to get them across the page. Okay, now the first one is the if W, then P. That's what we're evaluating here. And of course that's true unless P happens to be false when W is true. Well, let's look at P and W. Now here P is false and W is true. And let's see here, P is false when W is true. Those are the only cases where that happens. So we get our truth table for if W, then P. Then looking at the J and W columns in the same way, we see that the two false cases lie right here, and the true cases, well, every other case is true. And now we want to evaluate this conjunction here. Okay, this says this and this, which means that this, which is in this column, and this, which is in this column, both have to be true to make the and true. So let's find the cases where those are true. There's one, and here's one, and here's one. In every other case, at least one of the two is false. Just pointing to the falses to verify. Whoops, we missed one. Here's one where they're both true. Okay? So, trying to verify this when we found that we had a mistake. Now, the final line evaluates this conditional. And it looks like we don't have a line for if J, then P. And that's because I left it off when I set up the truth table. And it's a little hard to do that. So I'm going to kind of squeeze that one in here. I'm going to make a little column for if J then P and indicate that that's what we're squeezing in right here in between this column and this column. So if J then P, we have to look at the J and P columns and see, well, here we have a false coming from a true, and here we have a false coming from a true in the fourth line. First and third lines are okay, and then we don't have any more trues for the J. Whoops. So that all the rest of these have to be true. Okay, so I hope that that looks like a true, and I hope that this one does. Now we're looking at if this, then this. We have to look at this column, then this column. And we're looking for where this column, where the if J then P proposition is false and the conjunction is true. Is there a case where that happens? Well, you see that the conditional is false here, or the conclusion is false here, but the premise is false. Conclusion's false, premise is false. Those are the only two times the conclusion is false. In every other case, the conclusion is a true statement, and so there's no way to make this thing false. And we see that our final truth table, where we evaluate the entire argument, comes out to be true in every case. So this argument is a tautology. It's true in every case, and that means it's valid. So it's true in every possible case. So the argument must be considered valid. And this is our test. If we have one false here, there's a case where the argument doesn't hold, then the argument is not valid.